Okay, so in last video we saw that if we can mimic the learning behavior of humans in a machine, that means the ability to memorize pattern from data and generalize to unseen situation, that is what we call machine learning, right? So if a machine can have both, that that it can remember the past data and make good prediction on new or unseen data, that is what learning means in machine learning sense. Right, now we will move further, and based on the kind of data we have, we can generalize different type of learning problem, right, based on the data that we have. And the very first type that we are going to look at, what we call, is a supervised learning, right? And we have also other category such as unsupervised learning, and another one that we call is a reinforcement learning. So in few of our lecture, our main focus will be on the supervised learning, right? So let's try to first understand that what exactly falls under this supervised learning. And I mentioned that it depends upon that what kind of data we have, or you can say that what kind of learning our machine is trying to do from that data. So you will understand, do not worry. Let's go one by one, and let me take a very classic example of predicting the price of a house, right? So this is the problem statement, and this is our training data, and you must known from our last video that what we are calling it is the training data. So these data are nothing but just you can think of as a long record that we have, right? So we know that for this much of living area we have sold the house to 400 lakhs lakh, right? For this much of area we have sold the house to 330 lakhs, right? And so on, right? And from where we have these data has come up, from the past data, right? Where we have, maybe we have done some manual entries and all these things, right? So these are the past data, right? And that is what we are going to call it as a training data, because we are going to use this data to train our machine, right? Now now if you look at this problem statement, that predicting the price of a house, now uh, at this time it should be clear that predicting house price is not something we can easily express with a simple formula, right? We cannot just write down an equation where we plug in these features of the house and immediately get the price, right? Because the price depends on many factors, right? The price of house may depend on upon what kind of seasons are going on, what's the location of the house, right? Who is in the neighborhood, right? And what are the nearby facilities that we have in the nearby house, or maybe even the economic conditions currently going on in that country or in that place, right? So all of these affects the price of the house, right? So it is not just possible to write one fixed formula for that, right? So so that is why it it is it is a learning problem, right? We cannot just pin down a formula and we can say that this formula will work for every situation, every case. You just need to put the features of the house and you will get the price, right? So so this is what is the learning problem, right? And we can solve using the machine learning, right? We let the machine learn the relationship between house feature and their price from the data, and that learned relation to make efficient prediction for new houses. Right, and just for the simplification I have taken this one feature. We can have n number of features here: the living area of the house, how many floors are there, how many number of bedrooms are there. So we can have n number of such features. Just to make this simplification I have taken just one feature. Right, so the problem statement is, given a new house, can we predict what the price would be? So that is the problem statement, right? And we will see that through the learning we can have a robust system that can predict the price of the house efficiently. Let me take another example of, let's say that we just want to classify the incoming mails emails as a spam or ham. So this is the problem statement, that we just want to classify that incoming emails are, let me write it at emails as spam or ham. Ham means नॉन स्पैम, जो स्पैम नहीं है उसको हम लोग हैम बोलते हैं, HAM. Right, so this is again a problem statement, and now again this is again a learning problem. There is no direct formula that tells whether an email is a spam or ham. Right, instead we let the machine learn the pattern from the data. Right, so in this case we will also have the data set or the training data. Right, let's say that we will have this feature x1. So this feature x1 could be maybe, does the email contains the attachment? And we can have another features, like let's call this feature x2. So does email contains the word like money or price? Right, and so on. We can have n number of features upon which we are going to decide that if the email is ham or spam. And we have this training data, that means we have the past data where we have just classified few of the emails manually, right, by looking, and we have these examples where we know that a particular mail is spam or ham. If it is spam, we are going to say it is 0, and if it is ham, we are going to say it is 1. Right, so we will have this data, right, and from where we have got this data, maybe so from like, if you have seen the old version of the Gmail where it was not having the facility of deducting that if the incoming mails are spam or ham, right? So I think they do not used to have this kind of system where they were able to deduct that if the mail is spam or ham. So अभी जो है, अभी सिचुएशन क्या है कि ये जब भी आपके पास मेल्स आता है तो जीमेल जो है वो ऑटोमेटिकली डिटेक्ट कर लेता है और जो भी करस्पॉन्डिंग फोल्डर्स है उसमें फॉल कर जाता है ईमेल, राइट. अगर वो स्पैम है तो स्पैम में फॉल कर जाता है और काफ़ी इफिशिएंटली वर्क करता है वो, राइट. बट आज से बहुत साल पहले, बहुत साल मतलब आप एज्यूम कर लो 10, 12, 15 साल पहले इनके पास ये मैकेनिज्म नहीं था, राइट। बहुत सारे ऐसे मेल्स थे जो कि प्राइमरी फोल्डर में फॉल करते थे, राइट, और वो पूछते थे आपसे कि क्या लग रहा है आपको कि ये मेल जो है स्पैम है। तो अगर आप मार्क्ड एज स्पैम कर लेते थे तो वो इस डाटा को तैयार कर रहे थे, राइट, कि तो क्योंकि मिलियंस और बिलियंस ऑफ ईमेल्स जो है वो किसी के लिए भी मैनुअली प्रिपेयर करना, देखना हर एक ईमेल को और मार्क एज स्पैम और हैम करना किसी भी कंपनी के लिए वो फिजिबल नहीं है, राइट। सो व्हाट दे हैव given the user to option to mark if the incoming mails are ham or spam, राइट। सो उन लोगों ने ऐसे बहुत सारे डाटा को कलेक्ट किया, राइट, और जो भी ये डाटा थे एक्चुअल डाटा थे। अगर मेरे पास मेल आ रहा है तो मैं उसको मार्क एज स्पैम करने का ऑप्शन रहता था, तो मैं उसको मार्क एज स्पैम कर देता। अभी भी वो ऑप्शन है, अगर आप किसी मेल को मार्क एज स्पैम करना चाहोगे तो वो मार्क एज स्पैम कर लेंगे एंड they will have a new record, right, and based on that new record they are again going to train their model, and again they will have much more efficient predictions on the upcoming mail. So यहाँ पे ये मेरा बस एम ये था, ये समझाना कि ये डाटा जो है, ये पास्ट डाटा कैसे प्रिपेयर होता है, कैसे तैयार कर किया जाता है, राइट। सो ये दिस डाटा, द ट्रेनिंग डाटा, यू हैव इट, राइट। नाउ and you have this output label as well, right? So now if you look at these two example, that this first example and the second example, what's the difference between these two example, right? So if you look at the output, let me call the output y. So in the first case, this y can take any real possible values, right? So I cannot say that it will take from minus infinity to plus infinity, but it will take the any continuous value, any feasible continuous value, right? What the maximum price of the house or the minimum price of the house, right? But it is taking the continuous value. But in case of here, in case of the spam or ham, the label is taking, or the output is taking two values, either it is 0 or 1, right? So in case of this, the y is taking the value that are discrete value, right? So we can divide the supervised problem into two category based on the output, right? And the first category that we have seen is what we call is a regression problem. So this is a regression problem, right? So in regression problem, the output is continuous, right? And this is what we call is a classification problem. Classification problems, right? Here the output is discrete value. The y takes the value that is 0 or 1, right? It may take the value maybe 0, 1, 2, 3, any discrete, any number of discrete value, that it is not necessarily कि हम 0 और 1 मतलब दो ही वैल्यू ले, कोई भी डिस्क्रीट वैल्यू ले सकता है, एनी नंबर ऑफ डिस्क्रीट वैल्यू, राइट। So in supervised learning we have these two class of problem, that is regression problem and the classification problem, right? And you might have this question that why we call it as it a supervised learning. What is supervised here, right? So if you think about both regression and this classification problem, one thing is common for every training example. For every training example, we already know the correct output, right? That means we have supervision while training. So as the machine learns and make predictions, these known output act like a teacher or a supervisor, right? Guiding the model to see if its predictions are right or wrong, right? So that is why this type of learning is called supervised learning. And when we don't know the output labels, if we don't know have this kind of info, the what for our training data we don't know the output label, right? We just have the raw data without supervision, then it becomes the unsupervised learning, which we will cover later in this course, right? All right, so now to summarize supervised learning in a bigger picture, all supervised learning problem roughly follow the general process. So we start with a training data. So we will have the training data, and let's suppose that we have this n examples. We feed this training data to our learning algorithm, right? And the algorithm learn from the data and gives us a learn model or a learn hypothesis function. So this will give you a hypothesis function or a learn model. Let me write it, learn model, or we can call it as a learned hypothesis, right? And once we have this learn model, what we can do, we can feed a unseen data that our learning algorithm may not have seen from the training data, right? So we are going to feed unseen data, and we are going to predict the corresponding output of this new data, or we are going to estimate the corresponding output, right? So this process is common across all supervised learning, right? So the specific learning algorithm we will be using will depend upon the type of problem that we are going to have. Maybe it is a classification problem, or maybe it is a regression problem, right? But the big picture remains the same, right? Here, what will be the learning algorithm? Again, it will depend upon what kind of problem that we are talking, right? So in linear regression, our goal is to learn a function, we can call it as a hypothesis function, that can predict output as close as possible to true value. So there is some ideal function that we want to approximate, right? So we have this input, right? And we have this output. So we have this input and we have this output, and let's suppose that this is the ideal function that maps this input to output, right? And we don't know that what this function is. So what we do through the training data, or through the data that we have, or through the experience, what we do, we using this data, we learn a model, and to learn this model we are going to use the various kind of learning algorithm, right? And once we have this learn model, so what will be this learn model? So this learn model will approximate. So let me call this learned model. Let me say it like the learned model is h of x, right? So this learned model will approximate the true function, right? And we don't know, and we cannot find this ideal function, right? If we would have this ideal function, that we do not need the learning process, right? So through this training model, our learning algorithm will produce a learned model, and that learned model, let me call it as h of x, and that learned model will approximate this ideal model, right? And once we have this learned model, we are going to feed our unseen data, and that will give you the estimate of the output or predict the output, right? So in linear, in a regression problem, our goal is to learn a function, we can call it as a hypothesis function, that can predict the output as close as possible to the true value, right? And in classification problem, our goal is to learn a decision boundary or a hyperplane, right? So let me show you. So let's suppose that we have these features on the x-axis. So this is x1 and this is x2, right? And so we will have few of the positive examples, that is few of the mails that will be spam, and few of the emails that will be ham, right? So our goal is to learn this decision boundary, right? Or our goal is to learn this hyperplane that separates most of the positive example in one side and most of the negative example in another side, right? So in classification problem, our goal is to learn a decision boundary or a hyperplane, right, that separates the different classes, right? For example, one side for positive examples and another side for negative examples, right? And that is the essence of supervised learning. So in this lecture we will start. So now the next we will start with some basic terminology, and then we will move to our first supervised learning algorithm, that is the linear regression.